Hi everybody, Steven here. If you ever wonder what options you have for load balancing when we talk about NSX, what is the NSX native load balancer? What's this thing called the NSX Advanced Load Balancer? Where does AVI Networks fit into all this stuff? Well, that's what I'm going to cover. So stick around and we'll see you in a bit. Hi everybody, thanks for sticking around. So what we're going to do in this lesson, this is going to be mainly lecture only. We're going to talk about what the native load balancer is, what the advanced load balancer is, what's AVI, all that kind of stuff. We're going to start off with some basics. This could be a very advanced topic. This could go on for days and days. So I'm just going to give us the good overview so you understand the differences. Later on, I'll do some demos. We'll deploy the advanced load balancer, so on and so forth, okay? But for now, let's have the starting point. Let's talk about what the basics are, right? Now, I like to throw this out usually at this point. If this is stuff that you're interested in, or if you like this stuff, give it a like, but also subscribe to the channel. Really does me a big favor if you subscribe to the channel. Again, this is how we get monetized from YouTube. And again, I do have super thanks enabled. If you want to do that, that's an option. But let's jump right into it. So let me go to my iPad over here. Let's talk about what options we have when we talk about load balancers with NSX. Now, before we begin, we need to understand what a load balancer is and its advantages. Most of you probably already do, but there might be some out there that don't. So in this example, I've got my clients up here at the top, okay? So that's like you, me, whatever. And let's say you're going to go to Amazon or VMware.com or something like that. Typically, your load balancer is a device that will be sitting there between the servers you want to load balance across. Maybe these are your web servers, and the client. The load balancer will usually have like a virtual service or a virtual IP assigned to it. In this case, I've got a virtual IP of 10.10.10.10, and that's the IP addresses that my clients will use. Maybe again, that is abc.com, whatever. Okay. Then the load balancer will do what's called a destination denatting. Okay. So it will basically say, okay, it looks at the layer 3 information, says I got a source IP of the client, whatever that is. It's got a destination IP of 10.10.10.10. What it's going to do is take out that destination IP and replace it with one of the servers back here. It's IP. Maybe it'll put IP1 there. Maybe this is 192.168, whatever, 1.10, and this is .20 and .30 and .40, whatever. Okay? So then the packet will go over to that server. Now, when that server replies back, it knows what the client's IP, because the source IP was maintained or preserved, and we send that back to the client. Okay? So that's pretty much how a load balancer. And what's the advantages of having a load balancer? Well, one is performance, because we're going to balance the load across our servers. And how do you balance the load? Well, there's different algorithms it could utilize. It could do like round robin least connection, weighted least connection, depending on your load balancer, what features it has. Okay, and I'll talk about that stuff when we get later on into configuring all this stuff. So performance is one advantage of having a load balancer. How about availability? If this server dies, let's say this physical server, it's the web server 1, it dies on me, right? Well, typically there's monitors that are set up with your servers or your server pool, and this load balancer will be monitoring the health of that server. So if that server goes offline, it'll say, oh, okay, you know what? I'm no longer going to send any requests to that server anymore. I don't want to black hole any clients. I'll only use the remaining 3. And if this one gets repaired, then okay, it comes back online and away we go. So performance and high availability are the 2 big reasons for having a load balancer. Now, there's different ways you can implement load balancer. This one's called inline. Okay, you see the load balancers in line with the client and the servers. This is a very common one. Okay, there's also called a one-arm. If I just let me clear all this, a one-arm would be something like maybe you've got segments. Here's some load balancer. Here's some web servers. Maybe I got some clients here too. Clients. But then I also have, we'll do it in blue, my load balancer sitting right here. It's called a one arm. See how it only has one interface? And I may have multiple, let's go back to red, multiple segments with more web servers, more clients, wherever the clients can be, whatever the case may be, right? So this one arm load balancer, it's advertised in that virtual IP. So the clients, wherever the clients are, in the previous example, the clients have to be in front of the load balancer, and the web servers have to be behind it. In this one arm example, I don't care where the clients and web servers are. Now what happens is when the client comes in to the, let's say to the virtual IP of the load balancer, it hits that load balancer. This load balancer, because it's a one arm, it's going to generally do a DNAT, just like before. It's going to say, okay, the destination IP is my virtual IP. I'm going to change it to one of the web servers, okay? But it's also going to do, generally, again, depending on your load balancer, it also may do what's called a source NAT, okay? So it's going to say, okay, I need to change the client's IP now to me, right, to the load balancer. So when the request comes in, it goes, hits the load balancer, it goes, hits the web server. Now, if we had a direct return set, the web server would reply back to the client, but then the client would say, oh, who are you? I don't know you, and would drop it. So the web server replies back to the load balancer. This picture got a little messy. Load balancer replies back to the client. So a lot of times these one arms, I'm not going to say all of them, okay, because there are some that don't. A lot of times these one arm load balancer does both a destination natting and a source natting. So what's the advantages and disadvantages of each? The advantage of this solution is I can drop that load balancer anywhere I want. Just boop, plop it in wherever I want. I don't care. And I'm load balancing. Whereas the inline, you got to make sure that the load balancer sits between a client and the servers you're load balancing to. A lot of times it might be their default gateway sort of thing. So it may be a little bit more challenging or work to do. The downside of this one with the source natting is a lot of times, again, depending on your load balancer, okay, folks, because there's a bunch of them out there, it would, since it does a source NAT, it does a source NAT as well. It's changing the client's IP. Your web server only sees the load balancer's IP and not the client's. Again, depending on your load balancer, okay? I'll talk about that, some of that stuff later in the videos, in later videos. So again, you got. Let me go back to the picture. Again, generally you have an inline like I just explained, and then you have your one arm, which I just looked at as well. So that's what a load balancer is, just a really high level of view. There's a concept called the server pool. The server pool generally is, well, the server pool is your pool of servers they're load balancing to, right? The server pools will generally have monitors associated with it, so we can monitor the health of our web servers, whether it's just a simple ping to the web server, or you're actually going to be checking to make sure the HTTP service is running, sort of like doing an HTTP get command. Let's get this page, make sure we get a proper response. Just checking on my dog there, you know, that sort of thing, okay? So, and we'll take a look at that. Again, like I said, I could spend a week to just talk about all these things, but we'll take our time on it, okay? So, now, let's talk about NSX. When we talk about NSX, there's what they refer to as the NSX native load balancer. This native load balancer has been around for pretty much almost the very beginning of NSX. That's the one that ships with NSX. It's been around. Notice I said here, soon to be deprecated. So you'll actually see, let me actually go into my machine here. Let's go into here. Let me get my left screen here. Go on. There we go. So let me show you some differences. Okay, there's been a bunch of changes over the past few releases, right? So I'm just going to go into networking here. I'm on 4.1. Right now, I'm running 4.1, okay? I'm going to go into networking. Under here, you see load balancing. You don't see advanced load balancing. You see load balancing, right? When I click on that, you'll see there's load balancers. I can add a load balancer, create virtual services, create server pools, and so on and so forth. This is what's called the native load balancer. Notice it says right at the top, it is recommended to use the advanced load balancer as it is the choice load balancer and application security solution, NSX-T load balancer scheduled for deprecation in the future. What I heard is the next major release, so I guess that would probably be, you know, NSX 5.0 or whatever. Don't quote me on this, but again, just going by stuff I'm hearing, that this one will be gone. So if you're deploying new ones today, you don't want to deploy this one, okay? You want to deploy the advanced load balancer, okay? Let me show you what it looks like a little bit different in version 3. Let me just get this up and running here. Is that what I want? Oh, did I close my window? Yeah, so I'll show you that a little bit later on. Here we go. Yeah, actually I'll show you that later on. So this is the native load balancer. When we talk about the advanced load balancer, I go under system here under appliances, and I'll demo this in a later video on deploying it. You'll see this is where you deploy your, this is where you deploy your NSX managers, okay? But you'll see up here, advanced load balancer. This is where you can deploy the advanced load balancer appliance, and I'll talk about that. Let's go back to the iPad, okay? So the NSX native load balancer, again, it says it requires an edge cluster because, again, all that stuff that we talked about with your gateways, like your tier 1 gateway, as soon as you put a service on the gateway, it now needs an SR component. Again, if you don't know all that stuff, look at my routing 101. And the load balancer is a service, so it needs an SR component, and it runs on an edge. So that means all the traffic for that tier 1. So in this picture here, if I put a load balancer on this tier 1 right here, it's going to have an SR component for the load balancer, and that SR component runs on an edge, which is in an edge cluster. And it's going to run as active standby only, right? So all traffic, doesn't matter what segments are hooked up to this tier 1. If I got 10 segments, all traffic going in and out of that tier 1 goes through a single edge. And that might be okay, or that might be bad. So you got to really watch out for that. This, again, was the native one. It's been around for a very long time. I look at this load balancer as a very basic load balancer. It's kind of like, you know, hey, here's a free load balancer. It's not the greatest one, but hey, you know, it does the job, right? It's pretty good. It does certain things, but it's not like a full-blown F5 or something like that, right? Again, when I was teaching the class, I would tell my students, like, you know, sometimes I would get some students in there that their main priority was load balancers, and they would start asking me a lot of very advanced questions about the native load balancer, and I'd say, you know what, it's a mom and pop load balancer. If you're really looking for a more powerful one, then you have to kind of look elsewhere. At the time, I would say talk to a partner like F5, but today we have this other one called the NSX Advanced Load Balancer. So again, watch out for that. That one there, just what I call the native one, is going away, right? So if you're using that today, there's actually scripts you could run to transfer it over. I'll probably do a video on that. Now, what's the NSX Advanced Load Balancer? Okay, so where did this come from? VMware purchased a company called AVI Networks, okay? And this was back in, I think it was 2019. Don't quote me on that. But it was at VMworld where they announced it. I remember I was sitting there at VMworld when they made this announcement. So they purchased it. And AVI Network basically makes a software load balancer. But their software load balancer is a very high-end software load balancer. For example, the NSX native load balancer, sometimes people will ask me, well, Steve, can it be a global load balancer? And the answer is no, it's not. It's not like that whatsoever. Whereas AVI load balancer actually has the capability of being a global load balancer, and it has a whole lot more advanced features and performance and stuff. So VMware purchased AVI Networks, and they renamed their load balancer now to the NSX Advanced Load Balancer. This solution is truly a multi-cloud solution. I know VMware says, oh, you know, this is multi-cloud and that's multi-cloud. But I'll be honest with you, this product is truly multi-cloud, and I'll explain that in a second. Let's look at the components. If you're familiar with NSX, which I hope you are, we have management control and data plane. So same thing here. Now, and this is the part I really don't understand. A lot of the stuff I see from VMware and AVI, they don't mention anything of a management plane. They call it control plane only. Technically, it's management and control plane. So we have these 3 VMs here. And this is our, I'll call it management and control plane. And this is what they refer to as the control cluster, okay? So it sounds familiar, doesn't it? You have three of them, just like the NSX manager. So we have these three, and this is how we manage our NSX Advanced Load Balancer environment. This is where we're going to set things up, monitor, troubleshoot, get alerts, all that kind of stuff. Down in the data plane, we have these things called service engines. And what is the service engine? The service engine is basically a VM or VMs, a bunch of them. This is your load balancer, okay? This is where your virtual IP or your virtual service will be attached to. And then you got your workloads that you're actually going to load balance to. Okay, so the service engines is actually the load balancers, and they're VMs. Now, I said it's multi-cloud. It's truly multi-cloud. And the reason why I said that is because this could run on an AWS environment. It could run on Azure. It could run on Google. It could run on NSX. It could run on just a VMware environment, OpenStack, and so on. Okay, so what does that mean? That means these VMs here, there are appliances for all these different platforms. So you don't have to be just a VMware environment to run this. You don't even have to have any VMware stuff. You could be purely, AWS environment, then do this if you wanted to, right? Or you could actually have a mixture of these things. I could have a VMware environment and Azure and an IBM or whatever, right? So this is kind of cool when we talk about this, right? So this is what we kind of did, all right? Now, let's take a closer look at this cluster, okay? Let's talk a little bit about the cluster. And my first video will actually be deploying that. So let's talk about the cluster here. So first of all, it says the configuration of a 3-node cluster provides high availability and redundancy and is recommended as a best practice for production. I don't like the term best practices. So just like if you're familiar with the NSX manager, you know how we deploy 3 of those in a production environment, right? Same thing here. They want you to deploy 3 of them in production. You can deploy a single one if you're like in a lab environment or proof of concept. That's fine. But in production, they want you deploying 3. And it's the same kind of concept. You deploy 1, 2, and 3. If one of them should fail, no problems. We still maintain quorum, okay? But if 2 should fail, you're dead in the water. Pretty much exactly like NSX Manager. If for whatever reason, let me go back to this. Let's say I got 1, 2, and 3 appliances. If for whatever reasons, let's say one of the appliances, like this one, gets disconnected from the other 2, so it cannot see appliance 1 and 2, this one here will basically go into read-only mode. In other words, it basically says, I'm going to stop functioning and so on. So this way it won't create a split brain condition. That's why if you lose 2 of these, this guy, again, says, I can't see my other ones, my peers. The problem's got to be with me, so it basically stops doing anything. So this is why if you lose 1, you're okay, 2, you're not okay. I'll do a video on recovery and all that stuff as well, but it's a lot to cover for now. But anyways, so this is why you want to do that. Very similar to NSX. Controllers are delivered as a software with images available from multiple virtualization infrastructures. As I mentioned before, again, it's available because it's truly multi-cloud, right? So maybe I'm going to be running in a VMware environment. Maybe I'm running in AWS, whatever. Again, you could pick your poison. 3 separate controller instances are required. There's 1 leader node and 2 failover nodes. Configuration from the leader will be synchronized to both follower nodes during the cluster creation. Very similar again to NSX Manager. Now, I don't think I've done a video where I go in depth on it, but you have various services running inside your NSX Manager. One of the 3 nodes could be in charge of various services. That's kind of what they're referring here. So in this example, one of the nodes will be considered a leader. And technically, I don't really care who it is. All right. The leader has certain tasks to run. So runtime data store, it looks after that. The followers don't do anything with that. Infrastructure components, again, it's in charge of that. So post-read database, leader pushes replication to standby. Notice this is kind of orange. It means that replication service runs on followers because it's got to receive this stuff. That's one example of it. vCenter Manager. Okay, this allows the controller to talk to vCenter to say, hey, do this for me, do that. That runs on the leader. It's not running on the followers. If something should happen to the leader, a new leader will be elected out of the surviving two. Do I care which one? Technically, I really don't. Okay? So that's kind of what that is, all right? So like you said, you got 3 of them and you deploy 3. Now, you can, as I mentioned before, again, if you think about NSX Manager, very similar concept, right? You'll have 3 of them, 1, 2, and 3. They'll each have an IP address. Great. Now, you can also set a cluster IP address. So if all of these nodes are on the same subnet, just like NSX Manager, when you think about it, I could also set this virtual IP or this cluster IP, which will be bound to the leader. The leader will actually load that as a second address. So now all you have to do is access the controller cluster through this one IP or a fully qualified domain name that's resolving to that, FQDN. And again, if something should happen to the leader and the new leader becomes number 2, that cluster IP will basically be assigned to this node down here, and then we start going through there. So the first controller becomes the leader. That kind of makes sense. You add the other 2 after the fact. Very similar to NSX. A warm reboot of the cluster occurs during this process, which may take about 4 or 10 minutes. What they're saying here is very similar to NSX Manager. So when you deploy your first node, it's a cluster of 1. Same thing here. When you add the second node to it, you're now reconfiguring the cluster and say, oh, we're now a cluster at 2, and it restarts. And it takes about, close to 10 minutes. And then when you add the third one, it says, oh, okay, and we now have a third one, and it does the same process again. So very similar to NSX Manager. Configuration of the current leader node is then synced to the followers. Leader controller assigns the cluster IP as a secondary IP address. As I mentioned before, again, once you enable this cluster IP, the leader will have that assigned to its NIC. Again, I already mentioned about fully qualified domain names can be used. And it says nodes can be in different subnets. Okay, so this is one of the things I was thinking of. Suppose if each of these are in different subnets, maybe they're in different layer 3 networks, different racks or whatever, then just like NSX Manager, I can do that, but then I need an external load balancer to go to the cluster, okay? And you don't want to use this one as a load balancer. In other words, it's get a load balancer managing itself as a load balancer to manage itself, which would be like chicken and the egg scenario, right? So you can do it, but it does require an external load balancer, whether it's a global one or whatever the case may be. Okay, but you can do it. Think of it just like NSX Manager. If you're familiar with that, same kind of concept. Now, sizing. How do we size these things? Okay, so first of all, demo and evaluation, proof of concept, that type of stuff. Node count is 1. So here they're saying 6 CPUs, virtual CPUs, 24 gigs of memory, and 128 gig disk. So a pretty resource intensive type of appliance. And in production, you want 3 of them. Now, how big should it be? This is where the chart comes into, right? So they're saying the essentials, they have essentials, small, medium, and large. Notice over here, essentials, it says 4 virtual CPUs and 24 gigs. That means each of them, you got 3 nodes, each will have 4 CPUs, 24 gigs of memory. And it shows you a little bit, like, for example, the base processor will use up 15 gigs. The log analytics takes 9. Kind of shows you some of the stuff that's going to be using up the memory, right? But one of the main counters here is, what do I choose? Which one do I choose? It's going to depend on the number of service engines. Remember I mentioned service engines? How many of those we can have in environment? Maybe I don't have a whole lot. Maybe I have, something like less than 10. Then this will be fine. If I plan on having anything more than 10, up to 100, again, this is the size I would need, so on and so forth. Again, this is all inside the install guide. You don't want to get stingy on this because, again, this stuff is a database and it really likes memory and whatnot, okay? Disk size, now, how big is the disk? They talk about it in the installation guide. I didn't want to, it was just too much stuff to put into one slide. Typically up to 1 terabyte. Your disk is going to be storing logs. So the bigger the disk, the more logs you can store. And they actually go through some examples in the installation guide. So again, like a terabyte of storage is usually ample, okay? But again, it comes down to you, like how much logs do you want to maintain, right? So that's really what you got to kind of look at. And they go through some examples in the installation guide at the AVI Networks. Sorry, just do a search, documents AVI Networks, and you'll get links on it. What else did I want to mention here? I think that's about it. So now, when I talk about service engines, which is coming up, how many service engines do I need? How big are they, right? How much work can they handle? Remember, the service engine's the load balancer. And I got a slide kind of showing you that one as well. It gives you a good starting point. Let's talk about service engines, right? So we're right there. So the service engine is the load balancer. So it is a VM. It actually could be a physical box too if you really, really wanted to, right? So it handles all data plane operations within the NSX Advanced Load Balancer environment by receiving and executing instructions from the controller. Remember, the controller does not sit in the data plane. If the controllers die, the service engine still function. I can still access my websites. I'm still doing load balancing, okay? It performs load balancing and all client and server-facing network interactions, okay? Remember, I gave you my example of what a load balancer is. It's got the virtual IP there. That's your service engine when you think about it. Hosts virtual services, requires direct or routable access to all clients and servers. Yeah, that kind of makes sense because the client needs to hit it and it needs to talk to the web servers, right? So it needs access, routed access, at least to the client and the servers, your load balancing. It exposes virtual services to the clients. A virtual services could be like the IP address, right? Collects real-time application telemetry from application traffic flows. Remember, everything's flowing through it, so it knows what's going on, and it reports all that stuff back to the controller. So it's not limited to just load balancing. It does monitoring as well. And there's a whole list of different monitors. I'll do a separate video on that. But again, something as basic as, hey, let's just ping the web server and make sure it's there, right? Or it can be even more specific. Let's do an HTTP GET on a web page and make sure we get the proper response, right? Persistence request. When a client comes in and I ship it off to, let's say, the first web server, when that same client come back in, do I ship it off to web server 3 or back to the same? So you'll want probably some kind of persistence, but it depends on what your workload is, okay? Caches response content for potential reuse. Again, it can do caching. So again, if somebody makes a request on a web page and another person comes in for that same request, we don't have to go out to that server. We can just reply back. And you got different ways to set that up. Advanced security threats, denial of service, all that type of stuff. Web application firewalling as well. Offloading of encryption as well. There's a whole whack load. We could spend a lot of time talking about all the different options here, and there are some really, really advanced stuff. I will do some separate videos on some of these, but my first video will be setting up the controller cluster, and then we'll start deploying service engines and whatnot and setting up load balancing. So it'll probably be a couple videos just to get things up and running. Then we'll see. I'll see what the interest is like on YouTube, and then people can make requests, if they want to see some more advanced stuff here. Service engine sizing. Okay, so here they kind of give you a guideline. Okay, so it says metric connections per second. So one CPU core can typically handle about 40,000 connections per second. Layer 4 throughput, again, about 5 gigabits. Layer 7, that's your application, 3 gigabits per second. SSL throughput, about 1 gigabit per second. SSL transactions per second with RSA, about 1,000. SSL transactions with elliptical curve, about 2,500, right? This is a guideline, and the reason why I'm saying the guideline is because this says one CPU core. Well, hang on a second. How big is that core? How fast is it, right? So this is kind of a guideline, a good starting point. So here we give you an example. To achieve about 1 gigabit of SSL throughput, so let me clear all my stuff here. So to get about 1 gigabit of SSL throughput right there, and 1,000 transactions per second of SSL with elliptical curve, says they recommend 2 cores, one for each of these. Okay, so primary impact on what's really going to impact the performance is your SSL, web application firewall, possibly licensing as well. And it says CPU is mostly linear scalable. So if you have 2 CPUs here, you get 40,000, that sort of thing, right? So this gives you kind of a good starting point, all right, on the service engine, how big it should be, so to speak, right? Now, these service engines go into a thing called service engine groups. And the group, think of it almost like a template. Since it's a VM, the service engine group dictates to me the size of the service engine, how many service engines do I want to deploy, the level of protection I want, high availability, that sort of thing. So how big my load balancers are, the placement, high availability, that sort of stuff. Okay, like do I want active, standby, which we'll look at. So we create this thing called service engine groups, and there's actually a default one that you could use, or you can make your own. Each cloud will have at least one service engine group. What's a cloud? Remember, this solution is truly multi-cloud. So I can deploy my 3 controllers. Let's say, I'm at home here in a VMware environment. I can deploy my 3, and then I want to set up, maybe I got an NSX environment. I want to create a cloud connector to my NSX environment for AVI. And maybe I've got AWS as well. And I also want to set up another cloud connector for there. So each different cloud I have, whether it's VMware, AWS, Azure, or whatever, you don't have to have just one. You can have multiple. You need a service engine group in at least each of those because it's got to deploy service engines in those clouds. And I'll demo creating a cloud connector and all that wonderful stuff. Multiple service engine groups can exist within a cloud. Yeah, that's great. You could do that. And why would you want to do that? Maybe you have different levels of availability or performance. This service engine group is going to be looking after these workloads. This one that has more performance is going to look after this workload, that sort of thing. So it depends on what your needs are, but you have that flexibility. Provides data plane isolation when different applications are mapped to different service engine groups. Yeah, so it can have workload 1 is using this service engine group, workload 2 is using this service engine group. You now have physical isolation if you need that. Oops. The options within, I got a screenshot showing you service engine groups, and when I get into doing demos and stuff like that, you'll see various options. Now, certain options may be available in certain clouds and other options may not, depending on your cloud environment, okay? And a virtual service can be placed on a specific service engine group as well. So when I create my virtual services, which I'll do demos on that later on, I can specify what service engine group to use. Now, you can, and I'll probably demo this as well at one point in one of the videos, you can actually have a virtual service bound to a service engine group. So this workload is using this service engine group and it's using this virtual service, right? But hang on a second, I don't want to use that service engine group anymore. I want to use this one because it's better, it's faster or whatever, right? I can move that virtual service from that first service engine group over to second. However, there is going to be some disruption. You have to disable that virtual service to migrate it over. Probably a good idea to plan things out so you don't have to do it, but you can actually do it. And again, AVI does have some scripts available to do that if you want to. So remember, service engine groups basically dictates how big my service engines are. So when a service engine is deployed, it knows, okay, this is how much CPU I need, this is how much memory I need, boom, boom, it does it for you. So you can think of it almost like a template type of thing, almost. Now, here's a screenshot of some of the settings of a service engine group. I'm not going to go through all the settings, okay? I'll do demos and stuff like that much later on. But I just want to talk about high availability. Since we've got service engines, these are our load balancers. What type of high availability do I have? And a lot of this also depends on what license model you have. And I'll touch on that just briefly. But you have legacy high availability, active standby. If you've got a physical load balancer in your environment, that's what you might be used to. This is the active, here's the standby, right? You can do that, no problems. That's a very simple one. Or they got this other thing called elastic HA. And Elastic HA has two different ways of doing it. Active, N plus M. Okay? I'll get some examples of that. So let me just show you over here. Again, here's your settings. I want to do active standby, or I want to go or elastic, whether it's active, or N plus M. Then the other option here is this, which might sound a little weird. Placement, right? Compact or distributed. What the heck does that mean? I'll give you an example of that in a second. The last thing I want to show you, again, here you see the sizes of the service engines that will be in this group. Maximum number of service engines. Virtual services per service engine. So this is where you dictate, hey, each service engine is only allowed to run whatever, 6 or 7 or 10 virtual services. And the maximum number of service engines in this group is going to be 10 or whatever, okay? And there's different ways it can be deployed. So this is how you dictate how many service engines, how many virtual services can run on the service engine, and how big those service engines are, and the type of availability. But right now, let's talk about the availability option here. Let's start off with the first one, active standby. Pretty straightforward, folks. Right now, I got 2 service engines 1 and 2, okay? This is what I refer to as compact, the default. So active standby, all your virtual services run on the first service engine. The second service engine is just sitting there, really, not doing much, but it's ready. If this first one fails, then the virtual services are active on the standby. Pretty straightforward, active standby, okay? So that's what they refer to as compact. Distributed, again, that's these options right here. Distributed, excuse me, we're going to kind of mainly distribute the virtual services across there. One second, folks, I got a scratchy throat. Sorry about that, just coming off having a sore throat for 3 weeks. So in this example, when we deploy our first virtual service, let's say it's going to run on service engine 1, and this will be standby on service engine 2. Then we deploy our second virtual service, assign it to this group. It'll run on service engine 2 and be standby on service engine 1. So we're kind of, we're using both service engines. Both are doing tasks, which is kind of nice, okay? And again, if one should fail, well, what did we lose? We lost virtual service 1, 3, and 5. So they'll become active over here on this one here, all right? So very simple. This comes with the basic license and stuff. So by default, all virtual services are in compact onto one SE. That's an active standby. This mode, the active SE carries all traffic. The standby carries no traffic. Upon failure, it becomes active. And the distributed options allows us to not to concentrate all virtual services on one SE. So that's what that distributed and compact option is for. So active standby, that one there is not too much of a big stretch. Okay, let's talk about elastic HA. All right, so here in this example, I've got some settings I set up in my service engine group. Remember the screenshot I showed you. So let's say I said this service engine group is going to handle a maximum 18 virtual services. I'm just randomly picking some numbers here. And I'm going to set a maximum of 6 virtual services per SE. So I'm saying an SE service engine can only run 6 virtual services based on the sizing that I got. So what is N? N will be equal to 3 in this example. So I take the number of virtual services. This says 50 and it should say 18. Sorry about that. So 18 divided by 6 gives me 3. So I need at least 3 service engines to run all those 18 virtual services. Now let's just, for argument's sake, let's say this was 15, okay? Therefore, 15 divided by 6 gives me 2.5. I need 2.5 service engines. Well, you can't have half a service engine, right? So you basically need 3 service engines. You always have to round up. So to satisfy this number of virtual services, I would need 3 service engines. Great. But what happens if one fails? Some of the virtual services will be out, and I have to wait for a new service engine to be deployed. So this is where the M comes in. That's the buffer. That's the buffer. So if I say I'm going to have a buffer of 1, it says, okay, you need 3 SEs at a minimum, and you want a buffer of 1, therefore I need 4 SEs. And that's what you see down here in the picture. In this example, it says I deployed 9 virtual services. That's wrong. It's 4, 8, 12, 15. I deployed 15 virtual services. So, and that's what the green boxes are showing me, my 15 different virtual services I deployed, okay? And you see them kind of spread across all of these service engines. This is what the default setting for this is. Compact mode is off, all right? So that means it's going to spread it across all those. Now, what happens if there's a failure? So in this example, I lost service engine 2. Well, what got impacted? These 4 virtual services got impacted. So notice now they'll get reassigned. Maybe, you know, one of them was over here, got put on this one, another one was put here, and another one was put here. But then what will happen is we will spin up a 5th service engine, because right now in this example, if this one dies and we reassign the virtual services, the failed virtual services to the surviving service engines, what happens if I lose another one, right? It's going to be a bad day for me. So because I said I want to maintain a buffer of 1, it will spin up this 5th one. Now, there's a concept here I want to make sure. It says if in a write access cloud. So there's a thing called a no access cloud and a write access cloud. This means my controller cluster, does it have proper permissions or access to deploy these service engines? Does it have access to create the VMs? Can it create it, you know, in my VMware environment or my AWS, whatever? That's what the cloud is. When you're setting up your cloud connector, you specify if it's going to be a write access cloud or not, okay? If your controllers have write access, it could spin up this 5th service engine. If it doesn't, you mainly have to do it. In fact, you mainly have to spin up all service engines, okay? So that's a no access cloud. You got to manually do it. So a no access cloud, this won't happen, what I just mentioned. You got to do it yourself. In a full write access cloud, no problems. It does it for you automatically. Now, it's not just going to jump into that. If all of a sudden service engine 2 here has a hiccup, what it will do, the controller will say, hey, you know, haven't heard back from service engine 2. Let's reboot it. It'll try and reboot it. After 5 minutes, if it still hasn't heard back, that's when it kicks in and says, I'm going to spin up service engine 5 so we maintain that buffer of 1. Now, does it delete service engine 2? It will not delete it because you don't really want that happening. Maybe you need to troubleshoot why it locked up. So it will leave it there for you to, you know, look at logs or whatever. But after 3 days, it will delete it. So if you go, we'll check it out next week, it'll be gone, okay? So that's N plus M, okay? Active, again, if I just read through what I've kind of set up here. So I got, in this example, I got virtual services per SE, per service engine. I set it to 3. Minimum scale per virtual service is 2. Active means the virtual service is going to run on multiple service engines. Kind of cool, all right? So I'm saying I want my virtual services at a minimum to run on 2 service engines. So you see in this picture here, I got virtual service 1 running on service engine 1 and virtual service 1 running on service engine 2 as well. Virtual service 2 is running on service engine 3. Same thing, virtual service 2 is running on service engine 4. Now, if you look at virtual service 3, it's actually running on 3 service engines. I can do that. I can say, you know, the minimum it runs on is 2 service engines, but I can say, no, this virtual service is special. I want it to run on 3 service engines. You could do something like that. Max scale virtual service is 4 in this example. So if I'm spinning up virtual services, I can say, yeah, have this one run on, I want it to run on 5 service engines. It's going to say, no, you can't do that. We've set it to a maximum of 4. So you can specify that minimum, maximum range. The maximum number of service engines in this group will be 6, and compact mode default is on. Okay? So in this example, you see I've got 6 service engine in my service engine group, and this is actually going to be an interesting one for me to demo. Because if compact mode is off, it actually will distribute all the virtual services across all those service engines. It will spin up all those service engines as it needs it. With compact mode on, I want to keep things minimized. it will basically only spin up service engines as it needs. It may not spin up all 6, it may only spin up 3 or 4 or whatever. I'm going to do a demo on that, I think. So now we have a failure. So if service engine 3 here dies, well, what happens? I lost virtual service 2 and I lost virtual service 3. But hang on a second, don't freak out. They're already running. It's still running over here on service engine 4, and virtual service 3 is still running on these 2 service engines. So my availability of the application is still okay, but I might have a bit of performance hit. Okay, so what will happen in a write access cloud, the controller will spin up service engine 7. It says, I need to spin up a 7th one so I can place these virtual services 2 and 3 on it, and that's what you see over here. Okay, so it maintains that level of availability. So that's kind of cool. So that's what active-active is. And I'll do videos on these, demoing all this stuff, but it's a bit much to talk about right now. All right, well, I'm almost done here, and I appreciate you sticking around so long. And if you haven't already done so, subscribe to the channel. I appreciate that. Let's talk about AVI, or the NSX Advanced Load Balancer, from an NSX environment. Remember I said I don't need NSX to run the NSX Advanced Load Balancer. I could do it in just a VMware environment or a Google environment or whatever, right? But how does it relate to NSX? Because I'm an NSX guy. How does it relate to that? And this is where there has been some changes, okay? So first of all, let me kind of read through this and I'll show you some of the changes. So as of 4.0, the basic editions included. What does that mean to me? If I actually go to, just Google search, Advanced Load Balancer editions, right? You'll get, let me get this left screen here going. You can actually see the link here, right? docs.vmware.com. You can, whatever, you can do that. Here's the editions. These are the NSX Advanced Load Balancer editions. You see Essentials, Basic, whatever. Typically with NSX, now this may change, to be honest with you. You get the Basic Edition. And what does the Basic Edition give you? It gives you all this stuff here. What I want to point out is the Basic Edition that it comes with NSX. Notice global traffic man. In other words, is it a global load balancer? No. The Basic Edition isn't. The Enterprise is. Okay? So there's one thing there. There's a few other things, denial of service, all that type of stuff. What am I looking for here? Remember I talked about the service engines. We just went through it. I talked about active, active, active standby, N plus M. The Basic Edition for scale and high availability is Basic Edition, active standby only. Okay? So the license you get with NSX, if you've got the, I think it's NSX Advanced or Enterprise Edition, you get the basic license. Again, VMware is changing a lot of, their packages and licensing and stuff like that. Talk to a sales rep or a partner. But anyways, I just wanted to point that out. As of recording, NSX will ship, the NSX Advanced or Enterprise Plus will ship with the Basic Edition of the Advanced Load Balancer, but it does not give you a global load balancer features. And the SE is only active standby. The service engines are only active standby. None of that active N+1 stuff, right? Let's go back to this now. Oops. There we go. The second part I got here. As of 4.0.1, the NSX Advanced Load Balancer Policy API is now deprecated. What the heck is that talking about? This is where it gets really interesting. So NSX 3.1, 3.11, whatever, it shipped with the load balancer, the native load balancer. Fine, beautiful. 3.2 came out, and it shipped kind of like with both the native and the advanced. It's like, which one do I use? And let me show you. I'm actually on the VMware Labs. Let me just... Okay, so let me show you. I'm actually on the VMware Labs environment to show you this. Let me go to this screen here, left screen, webcam. Let me bring this over. This is a 3.2. I'm in VMware's NSX, or VMware Lab environment. This is a 3.2 NSX environment. Let me just show you system appliances so you know I'm not BSing you. So you can see the version right down here. Come on. Here we go, 3.2, okay? You notice over here it says Advanced Load Balancer. Now, let's go into networking, and you'll see in networking, so in 3.2, that's when they announced, oh, okay, we're shipping it with the NSX Advanced Load Balancer. So notice under networking in 3.2, it says Advanced Load Balancer, Load Balancing. What the heck's the difference? The load balancing back then, that's the old native load balancer, the one they're getting rid of, right? And the Advanced Load Balancer, that's the AVI Networks one, all right? So in 3.2, we had this in the interface here, and it says, oh, you need to deploy the appliance. Remember the controller cluster? So I would click on this and then come over to here. Come on. Give it a few seconds. And then I would click on, you can see it right there. I would click on here, and at that point, I would set my virtual IP, and I could deploy my appliance, okay? That's great. What's happened now? Let me get my other. This is as a 4.x. As a 4.x, so I'm on 4.1 right now. It doesn't really matter. If I go into networking, you don't see that Advanced Load Balancer. That's what it means. They got rid of the API for you to actually go in and let me just get that back up again. Yeah, so here's the one back. If I go networking, Advanced Load Balancer. Once you deploy the appliance, in here you could actually create virtual services and certain like server pools and stuff within the NSX GUI, right? Or you could use the NSX REST APIs. But then anything else after that, you had to connect to the AVI controller cluster to get all the metrics and do a bunch of the more advanced stuff, right? So some of the basic stuff was done in the GUI here. And it didn't kind of make sense when you think about it. Oh, we should have the NSX team doing a GUI in NSX and the AVI team working on their GUI in AVI, right? Just didn't make sense. So when 4.0 came out, they said, we're getting rid of that capability here, right? So in 4, you see, let me get that back up. In 4, you don't see that Advanced Load Balancer. I don't deploy it here. I can go to here. I can go into appliances. Come on. Give it a few seconds. And then I can deploy the appliance in here, just like before. But after that, for me to start creating my load balancers and all that kind of server pools and service engine groups, I go in the AVI interface. I don't do it in the NSX interface anymore. So that's gone. So just wanted to show you that, okay? So just wanted you to be aware. Let's go back to this. So that's what that bullet means. Prior to creating the cloud connector, yeah, so I want to integrate this Advanced Load Balancer with my NSX-T or my NSX environment. I got to create a cloud connector, right, for the NSX environment. So I got to tell the AVI controller cluster, hey, you're going to be using NSX-T. Great. What do I need to get set up before I create that cloud connector, right? And I'll do a video on that. I need to have the NSX transport zones all set up. I need to have my segments that my service engines are going to be connecting to. I need to have my tier 1 gateway, okay? This does not use an SR component in case anybody's going to ask. This is totally different, and I'll demo all this stuff. Typical environment, your service engine is going to have, well, at least 2 network cards, one for a management interface and one for the data. Remember I talked about the one arm environment? That's kind of what it is. So my first network card on my service engine, here's my service engine, is going to go to a management segment. So that would be an overlay segment in NSX. Yeah, an overlay segment in NSX. That's what I said. And then the data would be, again, another overlay segment in NSX. Okay? And I'll show you how we can deploy that because there's a couple of different options. And I'll demo this when I get to that video. That'll probably be my, not my next video, but maybe the one after that. We'll see. Now, topologies. As I mentioned in this previous one, you need to have a tier 1 gateway because that's what it has to attach to. So here's our service engines. This could be a service engine group. Okay? And here's my web servers. Notice my web servers are on a different segment than the service engines. You can do that. They're all sitting behind a tier 1 gateway. No problems. By the way, I can even have web servers up here if I wanted to, right? Okay, because this is a one arm. I don't care where the web servers are. Okay, so you have this as an option, Or you can do it like this. Here's a tier 1 gateway, and they're all on the same segment. All right? So when you look at this picture, your service engines can sit on the same segment as your web servers, let's say, or they could sit on a different segment. Really, the way I look at it, it depends. Do you want your service engines having the same subnet as your web servers? Yeah, great. This one here is less work because you just need the one segment, okay? This one here is just a little bit more work, but you'll have dedicated segments for the service engine. So whichever one you're more comfortable with. I don't know of any best practice in case anybody's going to ask. Haven't seen anything or recommendations on that. If I had to guess, this one here would probably be the one that, I don't like using the term best practice, but probably the one that is kind of recommended, right? And that's it. Thanks very much for watching, everybody. This is an overview on the load balancing options we have in NSX. By the way, if you haven't subscribed to the channel, please subscribe to the channel. I really appreciate it. It helps me out quite a bit. It allows me to keep pushing these videos forward. I need to hit a certain number in YouTube to get monetized. Right now, I'm not. But I appreciate those that have already subscribed. Really appreciate it. If you have questions, comments, write them down. If there's something you want to see or have me do or cover, leave comments. I'll do my best to get to it. I get a bunch of requests coming in. This was one of them, by the way. So now I've got more coming as well. So leave comments down below. Again, I have super thanks enabled, but thanks very much. Have a great day. Bye for now.